Good day. Now we will create a burglar alarm circuit. First, let's go to the website of EasyEDA. Then, you need to log in. Okay. Alright. After logging in, we will click this EasyEDA Designer. Alright. You can now see the standard mode or the start button with the standard mode and the change simulation mode. We will now create a new project. So for example, my new project is named new project, okay? Or I'll just name it as sample project. Okay, so this is my project. Then let me save it. Right. So after saving it, you can now see that that is your project inside this tab. Alright. Now, we will change the sheet name. We will rename it. For example, let's rename it as sample schematic. Okay. But you have to save it. I'm going to save it to the existing project. Okay. So again, so that is my name, right? So I'll just name it again or title it again as project sample, and that is inside the sample project. Okay. So you just need to save. Alright, as you notice, there's no asterisk already, and this is already your sample schematic name. Okay, so if you will check again the name of that, that's sample schematic. Alright, moving on. Okay, after editing the sheet name, let's edit now the template name. Okay, so I'll name it as burglar alarm. Okay, then of course okay, and this is the date. So you already edited the template. Let's move on. Okay, then we will now see that it is already your template. Okay, so for example, if ever you can edit your template, you can change it into portrait, but of course we usually select landscape, and then we will use the A4. Okay, for this example. Now, after that, we will create the circuit. Okay. So we need to look at the components for you to follow the schematic circuit of the burglar alarm. Okay. So let me continue. By using the website easyeda.com search, you will see that you can search the name of the particular component in the library. Okay, this is the library. Once you click the left tab, you can see a library. Then we can choose, for example, this one, EasyEDA. Then we can choose spy symbol. Then we can choose the system. And then we can type in, for example, battery or bat for short. Alright. So as you notice, there are already existing battery, but we will choose the proper media source. Or otherwise, I can complete this term. Or I can also type in again. Or I can type it here. Battery. Alright. So you can see that the system has battery multi-cell. Alright. So we will now choose this one. Then you have to click place. Okay. Just like to your schematic, you will arrange it the same. So now, I'm done in looking at the battery. We will now check how about the photoset or the PR sensor. Well, let me just type in like this. No results found, right? So what you're going to do, because you didn't know what is the keyword of that particular photo cell, you will search it using this link. Okay, so you can see that this is related photo self kit. Okay, photo self kit. Now we will go to your platform or EasyEDA platform, and then we'll choose the EasyEDA. We will choose the symbol. Okay, and then you will notice that it is already available. Okay, so I'll use this one. You can choose from each of that. All right. Okay, so I'll choose this. Then I can use command or something like R so that I can rotate it. Then I can place it there, and then I'll hit escape. Okay. So after looking at the photo cell, what is now my keyword for my 5K potentiometer? I hit search. So the keyword is just simple as potentiometer. So you go now to the library, and then you type in potentiometer. Okay, so you can see different kinds of potentiometer, but you need to look at what does it looks like. Okay, this is good, but I prefer to use this. Or there is no footprint for that, so I'll choose the one that has footprint like this. I'll place it, and I will place it somewhere in after the photo cell or the PR sensor. Okay, so I'll have it like this. All right, escape. Okay, so another component in our burglar alarm is the LM741. Okay, so what is LM741? That's the operational op-amp, right? So you will now search particular name for that operational amplifier. Okay. So you can see that the operational amplifier has the name LM741. Okay. So we will now use that one. And then I'll use the search LM741. Okay. I have to look where it has 8 pins. One, two, three, four, 5, 6, 4, 5, 6, 7, 8. But this one, if you choose this, there's no footprint. If I choose this, okay, I'll just choose the first one, alright, because of some of the pin connections. That's why I choose this kind of operational amplifier, right? So again, for our burglar alarm circuit, we need to look at the resistors. Okay. So as simple as you can type in resistor if I am not sure of that name in the library. I can use that again here, right? Or I'll just type in 10K resistor. If I have a 10K resistor, okay, so it's resistor underscore 10K. I'll search that one here. Resistor underscore 10K. Okay. So you will see now a different. Alright. Okay, so let me just omit the underscore. Or otherwise, I'll write resistor here. Resistor. There. Now I can see a resistor. I can place it already. So for my 10K resistor, how many resistors I should use in burglar alarm circuit? So I should use 1 and 2 and 3. Okay. And I should have another one here. Alright. And I think only 4 resistors. Okay. What is now the... But I should have 100K ohms here, right? So I'll replace it from the library. Let me check if there is another resistor there. Okay, so I'll replace the old one by this. Okay, so that's my resistor 100K. I have the variable potentiometer here. Then I have the 10K resistor, right? So how about capacitor? So you have to search capacitor. So for the capacitor, just type in capacitor. But our microfarad is 100. Okay? So I can type in just like this one. Capacitor. But it is microfarad. So it's not available in JCSC. How about this? Yun. Alright. So we can see positive, negative, but I would like to have the curve yan, right? Positive, negative, then place it. Okay. So I have the capacitor already. And then after that, how about the transistor? Okay. So for our transistor, again, let me search it first. Transistor, NPN. Okay, so I'll just use that keyword. NPN transistor. Right, so it's all available, but you need to pick the proper symbol. That's the symbol of for other manufacturers, and it's not actually the transistor. Okay, so you have to choose like this there, right? So this is a transistor. So I'll place it after the capacitor. Okay. Then what I need is a battery. Okay. Let me have, no, I need a buzzer, right? So I need a buzzer. Okay, so this is the buzzer. I just need to type in buzzer. Alright, so I can see a buzzer here. 4 pins. Yeah, I'll choose only 2 pins. Because according to our schematic, it has only 2 pins. Okay, so I'm gonna use this one. And then, since I need to identify the positive, negative, I'll place it like this. Alright? So, let me double check. I have the buzzer connected to the negative. Okay. I have the capacitor somewhere here. I have the resistor. I will place it here. Okay. I have the other resistor. I'll place it here. I have the operational amplifier. I will place it aligned to pin number 7. Okay. Then I have the potentiometer. The name of this is very long, right? So I'll just delete the rest. Alright. Okay. So you cannot or actually can delete this, but let us take it as is. Okay. So you can rename, for example, photocell. You can rename it 100K. This is a buzzer. So let me just buzz one. This is a transistor. Capacitor. Then I have the resistor, 10K. I will rename it as LN74 only. Okay. For the 10K, or I'll just have the space. Okay, I have the space. It might not understand the underscore for the value of the resistor. Okay. Measurement test. So this is B1. I'll name it as voltage or BCC. Okay. BCC, same as this. Okay. What else? Potentiometer connected to pin number 2. Then this is my photocell connected to the potentiometer. And then I'll have the resistor connected to 3. So I'll align it to pin number 3. Okay. Okay. So I can now do the wiring, right? So for me to wire it, I'll just simply type in W. For example, but I need to place first the necessary BCC of this circuit. So for my photocell, I need to have BCC there. For my pin number 8, I'll just place it here. For my resistor 100K, I need to have a BCC too. For my buzzer, I need to have it on the positive side. Okay. Alright. Then let me place the ground. Okay. So for the ground, I have the transistor. Okay. For capacitor also. Okay. Then for my pin number 4, then for my resistor 10K, and then of course for my battery or our source. Okay. So I'll wire it already. So make sure once you move your component, it's connected. I'll choose wire again. Okay. I have to wire everything. Then the photocell part is located to the potentiometer, while the other part is located in pin number 2. You have to connect this and this, right? And then I have to connect this to resistor, same as to the positive of the buzzer. Okay, then I'll connect it to the negative is connected to the collector of the transistor. Okay, then the base is connected to the capacitor, and at the same time to the resistor. Okay, then my 100K resistor is connected to the 100K is connected to this other resistor, and then this capacitor connected. Okay, escape, move the ground wire again, connect it, right? The emitter is connected to the ground as well as the capacitor negative. Then we have pin number 7 is connected to this. Okay. Pin number 1. Okay. While of course we have pin number 8 is connected to the BCC. Is it connected? Okay. While the pin number 5 and 6 can be connected to each other like this. Alright. While pin number 4 is connected to the ground, as well as pin number 1. Pin number 1, let us see, is connected to pin number 4. Okay. Okay, why not do first the number 4 pin? There. Okay. While pin number 3, what is left is pin number 3 is connected to in between the resistor. Okay. So I think I finished already my schematic diagram. Okay. So what you're going to do next is to simulate it. How you will simulate it? Just go to the start, but you need to save it first. Don't forget to save the project or your schematic. Make sure all of the nets are in good position or something like all are properly named. So let me go to the standard mode. Let me go to the simulation mode. Let me go again to the simulation or to the start tab to check if it is already in the simulation mode. And then you go to the project. There is already a simulation tab or menu. Then choose the run simulation. Haven't spice model using EELEAF. Okay. So sub-circuit code, sample schematic, ground, VCC, and so on. Alright. So when you see your nets, okay. So your resistor, where's your resistor? Oh, I forgot. I forgot to connect the other part of the potentiometer. That's why. Okay. So the other part of the potentiometer is located to the ground. So let me go back again to the standard mode for me to save it. Okay, so it's already in the standard mode. I forgot to connect this. So I'll place the ground here. This is connected to the ground. Okay. Then I'll use a wire again. Alright. What else did I forget? Okay. So let me simulate it again and let me check the nets. I just need to save it. Yeah. And after saving it, I'll go to the simulation mode. Alright. And then I will run. There is no spice symbol at libraries. So sometimes the EasyEDA are looking for the spice symbol, right? So I'll just write U1, U2, U4, and Q1. Okay, so U1, U2, U4, and U1, U2. I'll just write it on the notepad. It's looking at this spice model, but it's okay, no problem. Later on, you can see that it also checks in the footprint when you translate it or convert it into PCB. And click OK. Alright. So you have pin for the BCC. You have there the pin of this, right? Alright. It's not the same as of course, the PCB Express that you can click and ungroup the Actually, you can ungroup this, then check. You can edit and ungroup it too, but we will not going to do this list this time, okay? So this time, let me refresh the net, and then you can see your nets are complete. So you have 9/9 already. Okay, so it's already finished the simulation. Then you can see the trans 10M. Then you can also see that here, there, right? Then you can see that too. So it's looking something like the ground of the circuit. It's okay. Alright. So let me save it. And then let me go to the standard mode again. Standard mode. Once you go to the standard mode, you can now convert it to PCB. But it's looking, can find the footprint server. So BCC. So check footprints. Okay. So you have to check the footprint. So that's the question earlier. Okay, about the ground. Okay. So you have to write the pin number of positive is, for example, that has a pin number 1. And for the negative, that's pin number 2. So you have pin number 1 and pin number 2 already. So when I look at the battery, okay, so there are many pins. So I'll not choose that one. So I will choose this because it has only 2 pins. So there are 2 pins only, and then it's already connected to my battery. Then I can now update. I'll check update. Alright, it's already checked. And I'll close this. Then you cannot convert the schematic to the 3D or PCB, not unless, of course, there is an equivalent footprint. Once, I have to save it first. Okay, so I need to convert it. Okay, so you can stay as is, or otherwise you can change the width if you want. For example, the width is 63, then my height is 43. Apply. Right, it's okay. So I'll now transfer everything to the PCB board. So I'll do first the BCC. The buzzer is located. Okay, so it's based on the wiring. Where's my U? So I just need to rotate this. The buzzer is located there. Okay. Battery there. Actually, I can go to you can edit this. Okay. U4 at the top, somewhere at the top, U5 somewhere here, your Q somewhere. If I will rotate this here, okay. Capacitor almost beside the transistor there, okay. What else? What's this? Potentiometer. For my potentiometer, it's somewhere after photocell. We have the U there. This is the resistor. There, photocell. Something like this. And my resistors like this. Okay. No crossing. Oh, it's good. Alright, so already you can actually move it like this. Now it's crossing already. Cannot see the lines. Okay. Now you can already, there is what you call auto route. Let us see. Right? So skip next. Operation. Let me run it. There. Right? After clicking the auto router, it's already, there's already a connection, proper connection, and then you will notice that it is not in the 90-degree. Okay, after auto routing it or pressing the auto route, we will choose the copper. Okay, then you have to click it to the area of your PCB. Click each of the corner and then hit escape. Okay, so you can now see your PCB. Now you can now click the silk screen layer, then you can choose text, then you can edit the text, hit escape, click the text, then just edit as your initials or name initials, right? You can save it already, then click view. You can also choose 2D later, so check the 3D view, right? So for this, and then you have the go back again, then you can choose view 2D. So this is now your 2D view that is, of course, has these traces. Alright? That's it. Thank you.